All right, yesterday we left off with cooling, and I went over some PowerPoint stuff, and now I will make notes for you. So, all right. Cooling. Well, okay, so an engine that has, well, we'll say an engine that is overheated. Overheated what? One. So if you get them too hot, well, it has a breakdown in oil viscosity and destroys lubricating properties. Has a breakdown. Sure. Breakdown in oil viscosity and destroys lubricating properties. So it starts to overheat. Now your oil is going to go to crap. That's going to get worse. By the way, I forgot to mention, I didn't forget because I'm telling you now, so apparently I remember. Your engines that you have over there, when you pulled them out of storage, had 4 desiccant plugs in them, correct?
Yep. Yes.
And it had 4 spark plugs. Mm-hmm. Those spark plugs are garbage spark plugs used to plug a hole. Don't try and run the engine with them. There are 8 spark plugs you can use in the red toolbox that Aslan's group has, and Adrian's group, and Sherman's group. So don't try and use them. Everybody keeps asking, do you want to torque them in? No, just plug the hole. They're bad. They're no good. Don't try and use them. Also, talk about oil coolers and stuff. How many of you have noticed now that if you've looked at the sump on the light combing, your carburetor mounts to the bottom of the sump and it goes through pipe in there, and there's tubes that run through the oil.
Yeah, I've noticed that.
Yeah, well, that's going to do 2 things. One, it's going to warm up the air a little bit, which really isn't desirable because that hurts its the air density, but it does cause the air and fuel to become more atomized and mixed up better, so you get a better mix, and it does help cool the oil a little bit.
It's called an updraft carburetor, right?
It is in fact an updraft carburetor.
That's cool.
So, all right, the fuel, if you get crazy, the fuel air mix, this would be pretty hot, becomes preheated, because it's running through that oil sump, and pre-ignition can occur.
How hot does it have to be for pre-ignition?
Really hot, where the fuel air flashes. I have to look at what the flash point of the fuel is.
Boiling oil at that point, right? That's
Yeah.
like above 12 degrees.
Yeah, I don't know. I don't want to throw out a number. I just don't know.
Yeah.
Which then causes detonation. And that causes more heat. More heat when you have detonation. So that's bad. Obviously, it's going to weaken parts. I don't remember offhand what aluminum starts to break down at, but it's not far past, I think it's getting about the 500 degree mark. I just don't remember. It's somewhere around 500 degrees. The aluminum starts to break down. So once your aluminum breaks down, your cylinders are made out of aluminum. The aluminum heads, they start cracking, and then you're going to lose those. So may cause scoring. Pistons get all hot. They start to swell up in there. They swell up faster than the cylinder does. They start to seize up in there, starts scoring that's leaving transferring metal across the pistons. They get all ugly, and then eventually it may seize.
Metal goes into the...
Which means then that solves it, because then it stops getting hot at that point because it just locks up. I don't think I told this class about my engine seizing story.
No.
No, that's too bad. So, no, I usually, okay. So I wasn't working in the cylinder shop at the time, but you now understand, of course, that cylinders are standard and then they're bored oversize. Oh my gosh, it's been so long. Is it small Continental? I think it's 15 over. Not that it matters, but so we had a Globe Swift, and most of my horror stories seem to revolve either around a Globe Swift or a stupid Bonanza. But it was a customer with the Globe Swift. The Globe Swift is they're kind of just after the war. They're pretty cool little planes, 2 little seater, low wing. They were kind of made for the, hey, you just flew in the war with the P-51. How about this plane with a horribly underpowered, like some little 4-cylinder, I forget, but everybody's modified them, and most people put in an 0300 in them, which is only 150 horsepower. This one had an 0300, that's 6 cylinders. And it was in for whatever reason, and I know they were boring the cylinders over. And so when we bored cylinders over, we used our hone, and it does one at a time, and it had these a head that would go up and down around in the cylinder with these stones that would expand out. And it was partly automatic, partly a manual process. We had to control the pressure, and we had I'll bore you with it, but anyway, we had sine bars and all kinds of stuff to control the choke and stuff like that. But you can imagine, I mean, they would get hot because you're running these stones around through there, and so they would get hot. So the procedure was, at least with this guy, he and I did too, but you would hone it to near the proper size. And so what we do is just set it on there, and I would set it for like 200 strokes. And you'd run 200 strokes, and you'd do something else, and then it would stop at 200 strokes. You pull it off, do a bore check, see where it was, put it back on, maybe another 200 strokes, another 50. You just kind of had your judgment. And then a hot cylinder is going to be bigger or smaller?
Bigger.
Okay, so the measurements that you take on your cylinder is based on room temperature. So you can't have a hot cylinder. And they were hot enough that you wouldn't want to hang on to it, but you could take it off without gloves and off the machine and turn it around and set it down, but you weren't going to hang on to it. So it was always best to not do the final hone the same day. So you'd bring it up to very close, then set them overnight, then come in the morning and do a final measurement at room temperature, and then go. Well, that was the procedure. So this guy overhauled the cylinders, bored them oversized, put it all together, put the thing on, and it was out at Clarksburg. And, it was just one of these spring days. It was beautiful out, and we don't get a lot of air traffic. So, he finished the plane, pilot came, he'd take it, we just kind of go out there, take a little break, and, watch the plane take off. And I just remember a little white plane takes off, turned left, and cool, man, he turned the smoke on, his smoke system. And I looked at the guy, I'm like, how do you know that plane had a smoke system? He goes, it doesn't. It doesn't. He's like, oh my God. He goes, I totally forgot to finish boring the cylinders. He put it together, and it was only like, so they were bored to size when hot, but then they cooled down. They'll shrink about 2/1000ths. And so he didn't do the final bore on them. And so, the pilot can't see the smoke. He doesn't know. But, he came, he circled, and he was headed over to Executive, which is only 4 miles away. And he flew over, and the smoke was just pouring out of the bottom of the engine. It's seizing up already. And he saw his temperatures about halfway to Executive. He saw the temperatures going out of control. And so I guess he called an emergency, and he made it into Executive, put it in the hangar. And I went over there with that mechanic the next day to take it apart. And the only way we could get it apart, we had to take off all the studs on all the cylinders. And then we would have to hang on the propeller and pull it. And we could get one to go towards top center, but it would take the piston with it, the cylinder with it. And then we'd put blocks of wood behind the cylinder and then pull it the other way. And we just have to keep moving it in blocks of wood. And it was 6 times we had to do that.
So in between the base of the cylinder and
Yep.
the block.
You had to use the prop to force it out. So,
That's great.
yeah.
That's an example of improper break-in by the pilot.
Yeah. Spoken like a pilot. That's the pilot's fault right there. So, yep, it was seizing up. And oh man, it ate all kinds of metal in that engine.
That must have been a fun inspection.
It's funny, I don't remember that part so much, but obviously we took it apart and we just, took the oil cooler off, put it on a little parts washer, turned that on, rinsed it out, and hosed out the inside of the engine, changed the oil, put on some new cylinders.
You knew
It's good to go.
Yeah.
Air-cooled engines.
It's just the break-in.
Air-cooled engines. Okay, so there's more. I should, The thing is, and I love human factors, I really do. And human factors used to be more like, you screwed up, you're fired, you're punished, you're this. But modern human factors says, stop. Okay, how's this thing? Good things happen to bad people, and the higher up you get and the more responsibility you have, the higher your mistakes are going to be because you're given these tasks. You know, this could have never happened to the guy who just got hired last week because he would never be in charge of boring out 6 cylinders. You had to get to a very high level where you were trusted with the machinery to bore out 6 cylinders and put together engines. So, you know, with that comes this. So, in human factors now, we take a step back and say, how did that happen to this guy? If it happened to him, it can happen to anybody because he's a competent, good mechanic. So let's not punish the mechanic. Let's say what happened in the culture of our company that caused this to happen. That's how modern, how it is done modern. And so one of the things I did is, you know, when I got into that position, I said, well, I don't want that to happen to me, but it could. So again, I just sat down, and the boss loved doing it. I would just write out, hey, I want checklists. And I would just write out a formal checklist and say, this is now the checklist for boring out cylinders. Right? And it had to be turned in with everything, and you know, it had to have one other person check it. And again, having someone check it isn't always about having someone check it. You know, it's like if I finish boring cylinders, Oscar, come on, you got to check my cylinders. Like, dude, man, I work in the fabric shop. I don't know how to. So what? You're going to stand there and I'll explain the whole thing to you, and I'll catch my own mistakes, and it's exactly, you know, what prevented the next. It never happened again. So it works. So air-cooled engines. Well, most recip engines are air-cooled. Most turbine engines. All turbine engines are. Engines are air-cooled. So as long as you have enough air, C-O-O-L, cooled, you're fine. It's when you run out of air that you start having a problem, right? But proper cooling is dependent on proper installation.
As long as you're moving forward, you always have that.
Not always. Eventually it's not moving forward.
Oh, let's see. Proper care and maintenance. And so proper care and maintenance. Let's finish this. Maintenance cannot, well, it can be overstated. Well, it can be, because technically it can. It is one of the most neglected parts of an aircraft, I think, is the engine baffling. It's not pretty, it's not glamorous, it's horrible work. I don't enjoy doing it. In fact, when I did the baffling on my 182, I got my daughter to do it. You know, it's I'm like, hey, sweetie, you want to do daddy's baffling? You know, I had to stand over and show her how to do it, but, you know, it's because you get the baffle material, and if you're lucky like I was, I could take off the old stuff, which was nasty and stiff, so it made great templates. You know, I just drilled it all out, give it to her, and she just sat on the floor making patterns and cutting it. And she said, here you go. And nice. You know, and I'd put it on and, you know, rivet it. So, but yeah, it can be difficult because some of these pieces, they don't want to bend right, and you're fighting it. It's like, and baffling is expensive. But anyway, so it's never a fun job. But what are some of the parts involved? But you got to do it. And there's a lot of aluminum pieces that are broken and cracked, and you got to, you know. I got into my airplane, I'm looking at it, and I'm just like, you know, there's like a hole like that big, and that shouldn't be there. It doesn't, but it looks so nice, and I just kept thinking about it, and like, that just can't be. And finally I realized how a piece had broken out and cracked and made it just a perfect square. Like, that whole piece is missing, you know. So I had to put that in. We have the cylinder.
How much does it cost, like, to redo your whole baffling? How much would it cost?
The rubber baffle or the whole, all the metal and everything?
Just like the rubber
Just the
baffle.
rubber.
Oh, I'd probably charge 4 hours of labor plus material.
How much is it in an hour?
I don't know what shops are charging, 150 or so.
Okay.
It's really cheaper than a Mercedes brake job.
Yeah.
We have the bayonet type. Bayonet. And the spark plug washer type. And I told you about those yesterday and showed you a picture. Which one's better? Spark plug or bayonet? Yeah, the stick type. That's that little hole in the back, on the bottom of your cylinder that some of you are trying to plug up. Well, that's just blind hole. That's what goes in there. All right. A lot of times you only have one cylinder head temp gauge. Just says cylinder head temp, like my 182. Cylinder head temp. Where do you put the probe?
So cylinder head temp, I'm assuming.
You have 4 or 6 cylinders. Where are you going to put that probe?
Oh.
In the middle?
Yeah.
What if it's 4-cylinder? What's the middle?
How about cylinder?
Cylinder three.
The one closest to the fireball.
So, okay. If single unit, it's usually placed, usually placed on hottest cylinder. Light combing, it's 1, 3, 2, 4. It's usually the 3. The 4 is the furthest back. It's usually a 3, I think. I want to be careful I write that. It's usually placed on the hottest cylinder, but I should write this. Must go where certified. You don't get to choose. If it was mandatory equipment on the aircraft, it goes where the manufacturer told you to put it. That's just the end of that. If you're just buying one out of aircraft spruce and you're going to add it as a advisory piece of equipment, then I'd put it on the hottest cylinder. What's the hottest cylinder?
Whichever one's in the back.
It's not always. It has to do with the rotation of the prop.
Oh, really?
Yeah, so sometimes it's not the very furthest one back, but it's the next one forward.
So it's not the baffling and the way it directs the air through the
No,
cowling?
it's just because I don't know, just what I've noticed. You'd always think it'd be like number 4 on light coming, but I think it's usually number 3.
That's weird.
I could be wrong on that because it's being recorded, but I remember always thinking a lot of times, God, I would have put it on that one, but it's over there. So, ideal head temp, ideal cylinder temp. Okay, you should know this by now. What is it?
380.
You said 380. That's good. Under 400 degrees F, and that's what light coming says. Light coming. Service instruction 1049 delta. Not that it matters, but there you go. I wrote here, don't trust them. You got to be careful with probes. Sometimes they'll lie to you. Also, and I'll just throw this out there, if you are using the spark plug type, depending on your installation, like I said, some people may have like the Tanis heater I told you about, the heaters where the probes go. And so they'll have next to it, they have to use the spark plug washers. It's the only way. Or they may use the spark plug washer type on the bottom or on the top. There'll be like a 25 to 50 degree difference between having it up here versus down here. So installation matters. So you got to know that. Cowling. Cowling. It's a pressure cowl. P-R-E-S-S. Pressure cowl. What that means is high pressure on top.
Low pressure.
High pressure. Oh, you ruined it. Usually. Of course, there's going to be exceptions. What if it's an inverted engine? What if it's a radial? Okay, so radial is not top and bottom. And if it's inverted, the bottom is going to be high pressure and the top is going to be low pressure. But for our opposed engines, high pressure goes on top and then it goes down. So high pressure on top and low pressure on bottom, draws air through. You do have, and it's very important, this inner cylinder baffling. And I showed you a lot of pictures. I don't have any pictures of this, but around the outside of the engine. But in between the cylinders, there's also metal, and that metal is critical in there. And you'll see it when you put your stuff on your Lycoming.
Is it that the little silver fins that they put like in between?
Yep.
Okay.
Yeah. And what it's supposed to do is it actually makes the air go around the cylinders.
So we need to do that?
Yes, you do. So you got to force it through these fins and out. It's not enough to go through this space right here. So you have to block off that space between them so it forces the air in through here and down and around. Otherwise it doesn't work. Cowl flaps. Some aircraft have cowl flaps. I have way too much information for the time we have. I had operation. There's manual, electric, automatically thermostatically controlled. So, like in my aircraft, I've got a handle down here, and I can open them and close them. So, ground operation, takeoff, climb, I want them open. And so, if you look at the aircraft, they're just going to drop down. Front's that way. And so that the air comes through the cowling and out the cowl flaps. And then during flight at altitude, I can close them up. Problem with, like I said, my airplane with one old cylinder head temp gauge, I don't know what the cylinders are really doing. I mean, it just says CYLTEMP, and I don't know what the hell that is. And so I tend to fly with mine kind of open until I get my new system installed. But, a lot of the smaller planes, they don't have that kind of thing.
I've been on like a couple of little joyrides with people and stuff before, and I think I've heard people refer to something called Cal heat.
Cal heat?
Cal heat. I might be getting it wrong. No.
Carb heat.
Carb heat.
Carb heat.
Completely different.
Yeah, completely different.
Completely different.
We'll talk about that next time.
Carry
So cowl flaps, yeah, they can be manual. They can be, like mine, a little handle, or electric, little switch, or even thermostatically controlled, where they automatically sense the temp of the cylinders and they'll either drop down or come back up, which are kind of cool. Let's see. I'll put watch. Watch rigging. Something else that people just ignore. When I put my cowl flaps open, there's actually a dimension, how far they're supposed to be open. When I close them, how far they're supposed to be closed. A lot of times it's very, very off. So open during ground operations. And usually closed on cruise. Usually closed or partially closed at cruise. Cooling fins on the cylinders. Continental and Lycoming are very different on how they view this. You have to watch the overhaul manual, service bulletins. I don't want to go into that, but just put inspect. Inspect for broken, damaged fins, and follow service instruction. I'll just put SI, service instruction, because they're so different. 4313 talks a lot about fixing cooling fins. Can we use that?
No.
Not really, because Continental and Lycoming are pretty adamant about what's going on there. So follow them. One of them, I think, is Continental. You have to reject the cylinder if the fin is bent like more than halfway to the next fin. Now, you are not supposed to bend these fins. And it's just I'm like, ugh. Because, man, you just watch these mechanics. They just don't care. I mean, they're just forcing the wrench in here and backing the nuts off and bending this fin up to here. And it's like you could actually be destroying the cylinder. And you'd think it's just a bent fin. I mean, what's the hard out? Just take a duck belt, straighten it out. But if the manual says you can't do that, and you can't do that. All right, pressure baffles or baffling. I always think baffle is spelled funny. I always have to look. It's like baffless. That is the aluminum. I love waffles. Aluminum. I wrote structure. It's not structure. So it's aluminum baffles around the engine. some of this is just, I talked about yesterday. I don't want to take all night doing this. You obviously got to repair cracks as they show up. You got to fix this stuff. You got to take care of it because cracks just propagate. If you get a crack in it, stop, drill it. Crack gets bigger, patch it. You guys know how to patch aluminum now? Yeah? Some of you.
Yeah.
Okay. It's a good place to do it. I seal up all the little holes between the baffles and the engine. You know, sometimes you have to put spark plug wires have to go through the baffles, and so you know you need a 7/8 inch hole to get the 7/8 inch nut through there, plus a few extra wires, so you have a hole that big. Well, you know, put a grommet there and seal it up when you're done. So every little bit helps. The pressure baffles, we have the rubber seal. Flexible rubber baffle seal. It has to be formed in the proper direction, which is which way?
Forward.
Yep.
Towards the wind.
So usually forward or up if it's around the sides. Let's see. Replace when worn. Yeah, I wanted to buy a piece of in the carburetor heat box, as we were talking about. There's a little flapper, and we'll talk about that later. But you know, there's a little rubber seal in there, and I had to replace the little rubber seal on mine. And so I was going to get just a sheet of baffle material. It's a square yard. It's like $400. But that's okay because I ordered the actual Cessna part, which was only like $250. So you know,
Oh.
yeah, I was just saving money left and right there.
Yeah, that was a deal. Steal.
We have the inner cylinder baffles. I talked about those. Which direct the cooling air more around. The whole thing is designed to direct the cooling air around. All right, something new. An augmenter. An augmenter is something that uses exhaust gases. To aid in airflow. Aid in cooling airflow. That was a terrible way to write that. So I had to blow up, I don't know, an air mattress or some pool or whatever the heck it was with my son. He was a pretty little guy at that point, but a pretty smart kid. And so we had the air compressor out, and I said, I'll tell you what, I'm going to race you to see who can inflate this the fastest. I guess we had to do 2 of them. And so I gave him the air nozzle off the compressor and got it all thing. So I'm going to race him, right? So he goes first. So he takes the air nozzle, he makes a really nice seal around whatever we're going to blow up, and he pulls it, and you know, I'm timing him, and and he inflates it. Okay, done. Okay, time. Okay, good job. And then I took it, and and here's the opening, whatever I'm blowing, and I take the air nozzle I'm about this far away, and I aimed it at it and squeezed the trigger, and I inflated it twice as fast as him.
Mm-hmm.
Right? So what did I do?
Creates a low pressure zone.
Yeah, there's a low pressure zone, a Venturi effect, as I'm aiming it into here, which draws all the outside air in and inflates it twice as fast, or even 4 times as fast, really. So an augmenter tube uses that same principle of moving gas through something. An augmenter tube here. I know it's not in here. There we go. Augmenter tube. So what they're doing is they're shooting the exhaust. You can't really see it here, but shooting the exhaust down a tube. And what that does is, because let's just say it's coming out this tube right here, creates a low pressure in that tube, which has to draw air from somewhere, so it's going to draw it through here. So it just sucks it right through there. Hopefully you get that, because that's the best I can do. So yeah, these are the exhaust aimed out the augmenter tube, and you can see the cowling air then increases the airflow. So yeah, that's part of the cooling system.
That's cool.
So augmenter. Let's see here. Operation of air cooling. V. Oops, that's not the V because it's like some other number. Whatever number I'm on, I don't know.
Pretty good number, 22.
Operation of air cooling. It's dependent on the high pressure air. High pressure air. And where's that high pressure? Is it on the top or the bottom, usually? Top. Okay, so high pressure air. What's causing the high pressure air? The prop, forward movement of the aircraft, forward movement, pretty much. Because there's a limited amount of air pressure air you're going to get from the prop, but it wasn't designed for that. So a couple of things as I'm thinking about that. One, you know, if we have an engine, and let's make it a 4-cylinder, so you know I can do that. There's my cylinders. There's my rocker box cover, right? Look at that. And here's the engine. Okay. Little prop coming out of here. There. Okay. If you decide that you're going to run the engine without the cowling, which a lot of mechanics do because we're working on it, we have to do a test run after the fact and verify that you know don't have leaks, anything like that. Well, what happens when you operate an aircraft engine? I mean, it's got air, right? You're blowing air across it, but the air kind of goes like this.
So those back cylinders.
Back cylinders bake. They get nothing. Or at best, you know, that. So, but how is it supposed to be working?
Going over the top.
So it's supposed to come in and be forced around like that. So that's what it should look like. Big difference, you know. Or if we look, well, I guess we can add a cowling to this. This will be my cowling. So the air is going to come in the cowling openings. And it'll come up here, but this is all high pressure, and the same thing. It's got to force it down this way into the low pressure. And that's what it's got to do. All right, so running an engine without the cowling, you're not going to get much cooling. I don't care how fast you're going, how well that prop is going, you're not going to get much. That's why when you run your engines, we're going to take a little box and set it on top that at least scoops up some of the air. It's terribly inadequate because we're using a flight propeller, which the thrust is way out in the ends, and the base of the prop doesn't have much, but it's better than nothing. So it's really dependent. You got to have that high pressure air. How do you get the high pressure air? You got to have forward velocity. So don't want to do a lot of ground runs. When we test run engines on the ground, we use what's called a test club, which is on that engine that's, you know, vertical. Those square prop that's kind of funky looking.
Yeah.
More
Well,
thrust at the base, a little bit.
it's
or-
all thrust right at the base.
Yeah.
And so that will put a lot of cooling air across the engine. More than once, running an engine at full RPM, and our scoop has come loose from the engine and just destroyed. Just rips it right off the engine. It's kind of flapping. Like, whoa, shut it down, shut it down. Okay. So ground runs are bad. Let me see. Ground run. Ground runs. Can I put are bad? Because I kind of explained it. I don't want to. Ground runs rob the engine of cooling, like running a car without water. I guess it really makes a lot more sense if I actually write what I wrote. But anyway, test cells use large scoops or hoods, and then the test club. Helicopters. Much like air-cooled cars, use an engine-driven fan. There we go. Helicopter engine. Big fan. We run off the engine, so it's going to suck air in. See, come in here. Here's the cylinders right here.
Two?
Blow it across. Yeah.
Those are noisy.
The fans.
Yeah. You can hear them.
Can you?
Yeah, the little R22s and stuff like that.
Advantages of air cooling. What's some of the advantages? Nope, maybe write it.
20 gallons of.
What's that?
You don't need 20 gallons.
You don't need 20 gallons of coolant. So you get rid of 20 gallons of coolant. What else we get rid of?
Radiator,
Get rid of the radiator,
hoses.
hoses, leaking problems, water pump. So we get rid of a lot of things. That's one more component that could fail. You know, I guarantee you my cooling isn't going to fail in flight. Air cooled. Water cooling? Could happen. So weight. Also, we got to hang a radiator out of something. That's going to be drag. Okay. One book points out that air cooling, you would never guess this one, is less susceptible to gunfire. It used to be a problem. I do live in Stockton. Let's see. Few type certificated engines are water cooled, but more sport planes are. Yeah, sport planes. I forgot. You got your Rotax.
Oh, yeah.
So they're all water cooled. So the cylinders, of course, they're just like a car. They have a water jacket that surrounds the cylinder. That's got water and coolant, ethylene glycol. What kind of water do you put in there?
Distilled.
How do you get distilled water?
So leave it
It's our joke is, if you're those of you who are new, you leave it setting around for a while. That's not distilled water. Okay. Yeah, it's distilled water. Let's see. Yeah. All right. What time is it?
Early break time.
Okay, go on a break. Helicopter. Million parts rotating rapidly around an oil leak, waiting for metal fatigue to set in.
Rotating bits.
Oil leak.
It's funny because it's true. Okay.